de Broglie's explanation of Bohr's second postulate of quantization. It is very difficult to explain the Bohr's second postulate. It states that an electron can revolve only in those orbits for which its orbital angular momentum is an integral multiple of h by 2 pi times when n equals to 1, 2, 3, and so on. The quantization is why should the angular momentum can have only those values that are integral multiple of h by 2 pi. The question was explained by the French physicist Lars de Broglie in 1923, 10 years after Bohr's proposal. According to de Broglie's hypothesis, all material particles, such as electrons, also have a wave nature. C.J. Davison and L.H. Germer later experimentally verified the wave nature of electrons in 1927. De Broglie argued that the electron in its circular orbit must be seen as a particle wave. In analogy to waves traveling on a string, particle waves can lead to standing waves under resonant conditions. We know that when a string is plucked, a vast number of wavelengths are excited. However, only those wavelengths survive which have notes at the ends and form the standing wave in the string. In a string, standing waves are formed when the total distance traveled by a wave down the string and back is one wavelength, two wavelengths, or any integral number of wavelengths. Waves with other wavelengths interfere with themselves upon reflection and their amplitudes quickly drop to zero. For an electron moving its nth circular orbit of radius Rn, the total distance is the circumference of the orbit 2 pi Rn. A standing wave is shown on a circular orbit where 4 de Broglie wavelengths fit into circumference of the orbit. 2 pi Rn equals to n lambda, equation 1. N equals to 1, 2, 3, so on. Figure illustrates a standing particle wave or a circular orbit for n equals to 4. That is, 2 pi Rn equals to 4 lambda, where lambda is a de Broglie's wavelength of the electron moving in nth orbit. And we know that lambda equals to h by p, where p is the momentum. If the speed of the electron is much less than the speed of the light, then momentum p equals to mvn. Therefore, lambda equals to h by p equals to h by mvn. And we know that 2 pi Rn equals to n lambda equals to n into h by mvn.